This year, on April 10th, scientists were finally able to do the unthinkable. They allowed humanity to look straight into the abyss of a supermassive black hole and take a photo like a tourist attraction. But even after these accomplishments, we still don't know much about black holes at all, since one of them has challenged the whole scientific community with new impossible feats. In the middle of July 2019, black holes puzzled astronomers once again. New observations were made possible thanks to the famed Hubble telescope by a team of European scientists. Their study showed that a relatively small black hole, situated at the core of NGC 3147, contradicts all our expectations by almost completely mimicking its much bigger siblings. To show you how exceptional this discovery is, I'll have to start with the most basic question. What is a black hole? It's the tiniest and heaviest object possible in the universe. It can swallow entire stars with ease and is absolutely invisible to the human eye. But wait a minute, what was that giant visible orange thing in the pictures then? Did scientists deceive us with another computer simulation? No, not at all. The photos are as real as it gets, except the image in the photos is not of a black hole itself. I shall explain. Every black hole was once a shining star, just like the others you see in the night sky. At the end of its life, a star can collapse onto itself and condense all of its enormous mass into a tiny dot of space. Such an incredibly dense object will produce a gravitational force that will practically tear a hole in space-time itself and bend the whole matter of reality around it. From the moment of collapse, this monstrous gravity will attract and eagerly consume every piece of matter around it. Even the lightest and fastest particles in the universe, like photons, of which light consists, wouldn't be able to escape this unstoppable force. The core and center of mass of this black hole is called a singularity. This is the single cause of all the madness that's going on around it. The mass of this thing can be from hundreds of millions of the Sun's mass to hundreds of billions, and it takes so little space and volume that its density is almost infinite. No wonder this thing seemingly breaks all the laws of physics. In fact, the density is the most exciting thing about black holes. You see, it turns out that any object can become a tiny black hole if compressed enough. For example, our planet would have to shrink to 1/3 of an inch to become a tiny singularity of its own kind and start to bend reality around itself. Of course, this can't happen, but it happens to exhausted stars. The surrounding space near the singularity is the notorious event horizon. This is exactly why black holes are called black, though it's not entirely true. Normally, you can tell that something is black because this color doesn't reflect light at any of its wavelengths. The event horizon of black holes is black because none of the light that gets into them can escape. So, black holes aren't really black, they're just invisible. They're more than a tangible manifestation of nothingness for any light-sensitive device, the only one of its kind in the whole universe. The thing that makes the black hole visible, and is depicted in the recently released photos, lies beyond the event horizon. It's called the accretion disk. It's a brightly illuminated disk of matter swirling towards the center of a black hole, like when a giant drain forms a quasar. Quasars have their place among the oldest celestial bodies known to humanity, because their immense brightness can outshine even a whole bunch of stars put together. This brightness is achievable because all the mass that surrounds a black hole is rotating around it at 1/10 of the speed of light. A movement this fast leads to constant outbursts of radiation, and some of it shows itself in the visible spectrum as light and heat. Accretion disks consist mostly of superheated gas and space dust, and the speed of their movement increases the closer they get to the event horizon. The biggest and shiniest accretion disks are considered to have supermassive black holes situated in the cores of the biggest and brightest galaxies. And it's easy to see why. The more matter a black hole must feast upon, the bigger its mass. Its event horizon also gets bigger, and an accretion disk forms around it. This is exactly the reason why NGC 3147's black hole is so unique. It isn't supposed to have one, but it does. Let's compare some galaxies and black holes in their centers to further elaborate on this glaring difference. The brightest example would be the black hole in the middle of the largest galaxy known to us in existence, and the brightest galaxy of its cluster. This galaxy is so large that it would be hard to imagine it using just numbers. If this colossus were to replace our own galaxy, it would not only take the place of the Milky Way, but also of several neighboring galaxies altogether. This giant is the IC 1101 galaxy. When it was first discovered, it was taken for a huge orange nebula, an aftermath of the supernova explosion. It took several years to get to the shocking truth. The orange color we see is the light of about 100 trillion stars collected in one elliptical galaxy. Most of them look like ancient red dwarf stars, giving away their tired yellow and orange light. But the biggest surprise was hiding in the middle of it. The supermassive black hole at the core of IC 1101 suits its huge galaxy well. This terrifying monster is heavier than about 40 billion masses of the Sun. The accretion disk is as huge and luminous as can be expected. It's much like this same black hole from the photos. Only black holes this huge are sometimes called ultramassive, giving us a rare chance to visibly detect them. Let's move closer to our home for a minute. Our galaxy is much smaller than IC 1101 and not as luminous. The Milky Way is just 100,000 light-years across. Sounds like nothing when compared with the supposed 6 million light-years of IC 1101's diameter. But our galaxy is still rich enough to feed its black holes properly. The most notable black hole in the Milky Way is in the Sagittarius constellation, right in the middle of the spiral of stars that our galaxy is basically made of. We're 26,000 light-years from it, and it's more than 4 billion times heavier than the Sun, which makes it a supermassive black hole. Although Sagittarius's black hole is shrouded by gas clouds, blocking our view, scientists were able to get an image based on the radio spectrum irradiation coming from its accretion disk. And then we have the spiral galaxy NGC 3147, 130 million light-years away from us. This galaxy is small and not dense enough to constantly feed something as big and powerful as a supermassive black hole. Black holes in these galaxies are often called starving black holes for a reason. It's expected that black holes in a position this unfortunate can't have furious swirling accretion disks around them. It's far more probable that it would have some concentrated gas around it in a shape more akin to a donut and nowhere near as luminous. Still, against all odds, NGC 3147 has the same kind of accretion disk as its bigger siblings. According to our knowledge, this is almost impossible, and this galaxy was selected precisely to find a black hole with no accretion disk. But, as they say, there's no negative result in scientific research. Sometimes unexpected findings can teach us a lot more than pure success. For now, no one knows how this starving black hole can support this disk. To uncover the secret, Hubble stays busy searching for other galaxies with a lesser luminosity to find new black holes and see if they show similar abrupt qualities. It'll not only allow astronomers to study the accretion disks of starving black holes, but will also present a unique opportunity to test Albert Einstein's theories of relativity. The disk of NGC 3147's black hole is placed so close to the event horizon that the light it's emitting is twisting like nowhere else. This is exactly what scientists had been looking for. There's no better place to delve into the fabric of laws ruling the relations between time and space than a reality-bending black hole with such rare properties. How about you? What secrets do you think black holes can show us in the future? Wormholes? Another reality? Let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend. But hey, don't go getting sucked into a black hole just yet. We have over 2,000 cool videos for you to check out right here. All you have to do is pick the left or right video, click on it, and enjoy. Stay on the bright side of life.